There we go.
Remember this? This is 200 coin flips, which is essentially what you guys just did, yeah? 200 coin flips. 200 coin flips. Okay? Notice, if you go, and it doesn't matter if you go left to right or down to up, whatever you want to do. But how often does it go tails, heads, tails, heads, tails, heads, tails, heads? Or for that matter, how often can you find 10 flips that have exactly half and half? Let's try the first 10. There. That's 4 and 6, yeah? That one worked. That was half and half. That's 7 and 3. So it's not a promise that you're going to get 5 and 5, or 1 and 1, or 2 and 2, or anything like that. What is it a promise of? It's a promise that these numbers, over time, with a large enough sample, are going to average out to 50%. And that's what we saw last time is, as you replicate this, they do flop around quite a bit. But on average, you get purple in each cell, don't you? Because half the time it's red, and half the time it's blue. So on average, you get purple. So that's hard to look at. Let's turn that off. That's hard to look at.
Those aren't percents on the bottom, though, are they?
They are. It's 52% of what you're looking at right now is heads.
Why doesn't that equal 100?
Because of rounding errors on Excel.
Oh, okay.
It's rounded off to 2 decimals. It's not perfect every time. Sometimes it does. Thank you, Kelly. Sometimes it does, and sometimes it doesn't. Oh, crap. Let me open it back up again. Like right now it does. There it doesn't. There it does. There it does. It's a rounding error in some of those cases, and that's gonna happen. Sometimes the ones you're looking at don't add up to 100 either. It's just that they're off later on in the decimal. Whereas the ones did you hear what Kelly said? It was a very, very good point. It's just that it's just a mathematical rounding error.
Got it.
Cool? Now, I developed another one that might sit better with you. It's called the law of large numbers on a coin flip. Check this thing out. It's a similar result, but instead of looking at 200 flips at a time, it flips the coin once a time and keeps track of what happens each time. So if you look right here, this current flip, this is essentially what you guys just did. The current flip is generated by a random number command, ran between 1 to 2. If it comes out of 1, we're going to call that a heads. If it comes out of 2, we're going to call that tails. So every time I press F9, he's going to flip the coin. What I want you to do is I want you to watch this coin right here. That placement of that coin on the graph is going to indicate the probability of heads after a certain number of trials. So we're going straight empirical. We know it should be 1 out of 2, right? 50%, and that's the black line I've placed across the middle right here. So our gut tells us it should be heading right to there, yes? That's our gut. The question is, let's see if randomness actually shows up on that. Now, you see what just happened? It went from 0 to 100, back down to the middle again. Now watch what happens. Yeah. What's happening, friends?
It's averaging out.
Yeah, it's beginning to average out, and it's beginning to follow the line. And that's exactly, we're going to let it go off the screen here. That's exactly what should happen over time. It should average out and follow the line because it has to, assuming the random number generator is randomly generating numbers between 1 and 2. And the further out you go, the closer it's going to get on average to that 50-50. So when you quote that a coin has 50-50 chance of getting heads, you're actually quoting that long-term run of probabilities. But you can't guarantee anything. Aaron said, I got a pattern over here. It was tails, heads, heads, tails, heads, heads, tails, heads, heads, tails. And it's extraordinarily, my son, it's a pattern, Daddy. I'm like, well, well, buddy. And he's discovered the coin flip game on the phone. The reason I have that on my phone is because he put it on there. He now has a game. Dad, let's play coins. And he'll flip, and he'll say, pick one. And he's figured out that he loses half the time. That's a wonderful thing for a 6-year-old to understand. And then he tries to start cheating so he wins more. He starts flipping. He starts chasing the results he sees a lot of. So he starts, when like 5 or 6 heads come in a row, he switches to heads. I'm like, I wouldn't do that, buddy. Regression to the mean. He's like, what? And I try to explain the Sports Illustrated thing to him, and I forget he's 6. He doesn't understand this crap. But that's the thing, you can't chase those results. I put a 243 quiz up for this week called about the Gambler's Ruin, which I think I mentioned to you guys. The Gambler's Ruin, it's a surefire way of winning $1 in Vegas. I didn't tell you this? Here's a guaranteed way for you guys to win $1 in Las Vegas. Walk in with a bunch of money. Go home. Then you won. You got a bunch of money. But if you're dead set on winning $1, go play craps. Craps bet. Do a pass line bet. We're going to analyze that next week. Pass line bet is the fairest bet in Vegas. You'll see why next week. The fairest bet of chance in Vegas. Essentially, we'll examine it next week. Let's just say it's 50-50 chance winning. It's not quite. It's a little bit below 50-50, obviously. But bet $1 on a pass line bet. It's 2-to-1 payouts if you win the pass. Actually, it's a 1-to-1 payout, which means they'll give you $2, which means you profit $1 if you win. So if you win on the first roll or the first game, you get $1 back. Go home. You spend $1 to win $1. All is well. All is well, right? But if you don't win, which is going to happen roughly half the time, double down your bet. Now bet 2. So now you're $3 in the hole. You bet your first $1 and lost it, and you bet 2 more. But the thing is, if you bet $2 and you win, they're going to pay you 4. $4 eradicates 3 of the ones you lost, and you profit $1. But that's if you win. If you don't win, double down again and bet 4. Now you're in $7. But if you win, you get $8, which means you profit 1. So you see, the problem is it costs you more each time to win back that $1 with each passing roll. And the question I had for 243 is, on average, how much does it cost you to win back $1? And the answer is freaking awesome. And you can imagine what the answer is because it's called the gambler's ruin. So you can imagine what the cost is to average back a winning of $1 if you can. Because theoretically speaking, you can keep losing, can't you?
Mm-hmm.
It's like flipping.
Until you run out of money.
Which is why it's called the gambler's ruin.
Yeah.
Like $100.
Which is, say that again?
Like $100 to win $1.
I don't want to give the answer away, but the solution will be posted at the end of this week. Speaking of which, I apologize. I didn't get a chance to link the solutions to last week's quiz until this morning. They were uploaded on Friday, and I never got a chance to actually upload or put the links in until this morning, but they're there. I'll have the link solution for that one next week for you guys so you can see it. It's freaking rad. It's a rad mathematical problem, and if everybody that walks into a casino in Vegas would understand that, they would know when to stop. I'm not saying don't go to Vegas. I'm like, go there knowing you're going to walk out poorer than you walked in. On average! That's the big idea, right? And Vegas knows that.
Casinos are there.
That's why the lights are on all night. That's why they pump water in from LA all the time. Think about Vegas, where it sits. It's in the middle of the freaking desert. They've got a fountain outside of the Bellagio that's bigger than most cities. In the driest town on earth. Well-ish. Alright. Now, let's shut this stuff down for now. Let's change the experiment. You've got a bunch of coins in front of you, yes? Now, let's change the experiment. I told you to have 4. Let's go to 2. What I want you guys to do is I want you to flip either 2 coins at a time or 1 coin and then a second coin. But keep track of your results in pairs this time. So either flip a coin once and then once again and then write down what you get, whether it's heads, tails, 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 whatever you get. Write down what you get. Or flip 2 coins in a row if you're feeling like quick draw McGraw. And let them fall and write down what you get. Okay?
How many times?
Do it 10 times again. 10 times again. Well, actually, we got 1 plus 3 is 4, plus 5 is 9, 11, 14, 19. 19 people, of which 10 flips each is 190. Is that fair? Yeah. Now we're going to do this next one actually in the calculator completely. If you guys want. Maybe we won't. We'll have to see. We'll have to see.